Hello everybody, this is the notes for section 2.4, Algebra 2 Trig, operations with functions. So we talked about what a function is, how to recognize a function, whether you're looking at a table, looking at a graph with the vertical line test. So now we're just going to do some things with those functions. It's pretty straightforward, it really is. It's a matter of just kind of looking at some notation. So the operations, add, subtract, multiply, divide. This is what you'll usually see, f plus g. You just take function f, whatever it is, add it to function g. Same thing with subtraction. F of x minus g of x. Hang on, Mr. Shinkonis is interrupting. Okay, done with that. Jeez, that guy's so interrupted. When you are adding and subtracting functions, the biggest thing is just you're adding and subtracting, so you can only add and subtract like terms. Same power, the variable, same variable, those kinds of things. With the product rule, it's just a function times a function. Look for distributive property, those kinds of things, or that kind of thing. It's usually about all there is. With the quotient rule, there is something a little bit differently. You cannot divide by 0. So this function, f over g, it only exists when that denominator function g does not equal 0. And so the question is, what are the x values that make function g equal to 0? Becomes part of the restrictions of the function. So we're talking about domain with that thing, and we'll do an example of that. All right, so given two functions, f and g, we just want to add them up. All right, so function f is 4x squared plus 6x minus 9. We are adding that to function g, 6x squared minus x plus 2. And like I said earlier, it's just like terms. We got our x squareds. We have 4 of them. We're adding 6 of them. That gives us 10 x squareds. We have our x terms. 6x plus a negative x is a positive 5x. And we got our constants. A negative 9 plus 2 is minus 7. That problem's done. Okay, that's really all there is to it, just adding or subtracting like terms. Remember, with addition, commutative property exists, meaning f plus g, g plus f, that is going to end up being the same thing. That kind of property does not work with subtraction. So pay special attention to the order in which you're doing things. And there's an extra thing you got to pay attention to with subtraction. And kind of why I put the functions in parentheses in the first example here. But function f, 4x squared plus 6x minus 9. We are subtracting this whole function g. Okay, and this is what I mean by be careful with this. Putting the parentheses there helps. You are subtracting everything. That means you're going to subtract a 6x squared. You're going to subtract a negative x. You're going to subtract a 2. You got to pay special attention to that. It's an easy mistake to make, so don't. So, again, like terms. We got 4x squared. We are subtracting 6x squared. That's a negative 2x squared. We have 6x. We are subtracting a negative x. So that becomes plus 7x. We got a negative 9. We are subtracting 2. That becomes minus 11. All right. That's the addition and subtraction. For multiplication and division, I forgot to mention it in the last slide, but hit pause, try these problems yourself, and see how you do. All right, multiplication, same kind of setup. We got function f, 9x squared. We are multiplying it by function g, which is 4x plus 3. And so this is basically just a distributive property. You got 9x squared times 4x, 36x cubed. Then you got the 9x squared times 3. We're adding there. That's going to be a 27x squared. They're not like terms, so done. Okay, for the division, It's not really complicated, but there is a little bit more to it. I went too far with this. I need to see the original functions. So for f over g, so we take our function f, 9x squared, we divide it by function g. That's a terrible 4. 4x plus 3. Okay, that's our function. One thing you always want to look for is any common factors in the numerator and denominator. And we don't have any. This 3 is not a factor of the denominator, so we can't cancel it out. It's just a term in the denominator. We couldn't cancel out with a 9. So there are no like terms, but there are restrictions. Your denominator cannot equal 0. So the question is, what values of x make that happen? So what we're going to do is just set the denominator equal to 0 and solve for x. What we get is a negative 3/4. This negative 3/4 is the value of x that makes the denominator equal to 0. You can't divide by 0. So x cannot equal a negative 3/4. This is your answer. All right. The question was, what is f of g? That's it. State any domain restrictions. The x values that make the denominator equal to 0. All right. That's it for this first one. The next video is going to be about composite functions. It's a little bit of a different thing, but please watch.